All right. Well, this is a talk that will cover some of my experience building digital platforms. In this case, I've been building digital platforms that deploy microservices architectures for about 4 years right now, and I basically have been observing some patterns across all these projects, and I have documented some of them, and this is a presentation about my experience doing that. So let's begin. So for starters, what is a digital platform? Well, in this case, a digital platform is basically the runtime for the microservices, right? In this case, we have the building blocks for a microservices architecture. You have a cloud provider or an on-premise infrastructure. You have a platform that could be as a service too, and the runtimes on which the applications run. What I mean by the runtimes, it could be like if you're developing for the Java virtual machine, it will be the virtual machine itself, or if you're using JavaScript, it could be Node.js, right? And it's also something else. It's also the cross-cutting concerns of your applications. It means that within the platform, you will have things like authentication and authorization, you will have tracing, and you will have logging, and other stuff that is a cross-cutting concern across all your microservices. In that case, the set of all of these technologies, that's what a digital platform is. While building these digital platforms, what I've been observing is that we have a lot of patterns for the microservices themselves. As you can see in this slide, we have patterns for data management, we have patterns for deployments, and we have some patterns for cross-cutting concerns. In this case, the examples that we have here is basically what we have for patterns was like the microservices chassis, which is, you could say, a pattern that applies to all the microservices with the platform, but it's not exactly what I mean with patterns for delivering microservices, because this gives you like the structure that your microservice will have, but it doesn't give you like the structure of the platform around it. Like it doesn't provide you like things specific for your enterprise or things that are specific to all the platform around the microservice. We also have another example here in services deployment platform. It kind of tells you how to modularize your microservices in such a way that they are oriented towards services, but it's also not something related to the building, deployment, and release of those services. That's what I want to make a difference here. We have a bunch of patterns for microservices, but not patterns for delivering those microservices into these platforms. In this case, what I found is that we have a bunch of patterns that I like to call them digital platform accelerators, because they provide you a way to accelerate the adoption of the platform by the people building the microservices. This is a graphic that I like to show in this talk a lot, and you will see this a lot because basically whenever you create new characteristics or functionalities into your platform, there is always going to be people that are going to adopt this, or in this case people or teams that are going to adopt this, which are going to be the innovators. And then you will have this curve all across the microservice that you're implementing, and you will see people adopting things earlier and adopting things fast, but there will be other people that their microservices are stable and they usually take a lot some time into adopting the new characteristics of the platform. But the idea here is that it will be a curve, right? Not everyone will go into the wagon at first, but eventually what you want is to keep people in the early adopters, or people adopting the stuff that you put in the platform as fast as possible. And that's the idea of the accelerator. It's basically helping people to move to adopt those characteristics. So in this case, within those digital platform accelerators, I have divided them into 4 categories, and I have examples of those, of the things that I have implemented, and these are the patterns that I have been observing. In this case, the categories are project Kickstarters, which will allow you to create microservices or bootstrap those services fast. We have delivery workflow tools, which is basically taking the newly generated microservice and then create a paved road to production and make it easier to deploy on all the environments that you may have in your software pipeline. Then another pattern that I have observed is what I call a microlibrary. There have been some discussion about this in my work and other forums where I have said like, oh, this is the definition of a microlibrary, and then people come with different definitions, but I have this specific separation just focused on the platform itself. I will explain about that later. And then finally, I have distributed refactoring tools, which are things that or tooling that have use across the platform, because there is a pattern in all of these accelerators that keeps you from having early adopters of your platform. I will discuss this at the end. So let's start with project Kickstarters. Project Kickstarters are a way to create services fast, right? It could be a conceptual template. It could be code generation, but the point here is that they allow you to bootstrap projects or bootstrap new microservices fast. And why do you want this? Because you want innovation, right? In this case, you want services to be deployed fast to production so that you can start gathering data and you can start having customers using your new functionality. And these Kickstarters are basically what bootstrap these new projects into research and development, and they put them into production. So basically, I have implemented code generation, but tailored to the platform itself. What I mean by tailor is basically that you will not use, let's say, code generators that are too generic. Let's say in the case of start.spring.io or JHipster or something like that, you're tailoring those generators to be used within your platform, and they will have, I will say, a set of best practices that you have used across your platform and a set of technologies that you have blessed to be used within the platform, right? Because you have made technical decisions and you have a set of technologies that you want to implement. Or that you want your microservices to be implemented with, and those are that's the tailoring that we have here. Also, they will evolve with your platform. So whenever you need to add, let's say, cross-cutting concerns within the platform, or you want to add something into the platform itself, a new characteristic, that characteristic is usually implemented in project Kickstarters first, so that other microservices can be generated from those. In this case, well, the first project Kickstarter that I have implemented within platform development is templates. And basically, those are blueprints for your application, right? What do I mean by blueprints? It's basically what I said before is you will have a project that is going to be the basis for other new microservices. And that project is usually divided into the types of microservices that you will have. You will have atomic services, which are basically independent microservices that they maybe have data storage or something similar, but they don't depend on other microservices to work. You will have API composition services, which are going to be like your middle layer when you're trying to aggregate the data from atomic services. You will have micro frontends. That's another type of template that I have implemented, and those allow you like to expose web applications. But in this case, the micro frontend pattern is something that is relatively new. But that also you will need a template for that, because the idea is that we'll have a web page composed of various microphones, and you want those microphones to be generated and bootstrap quickly, right? And finally, another example of this is a Saga orchestrator. As you know, there is a pattern in microservices called Saga. Basically, it means that you need orchestration between various business transactions, and you want to keep logs of those transactions, and you want to make these long businesses processes run and be orchestrated with, right? And you want to avoid having share databases, and that's why you need the Saga pattern for that. And those are usually the templates that I have created in my work on building digital platforms. And then you also want to have templates with cross-cutting concerns, right? These templates will have logging, tracing, authentication, and other kind of boilerplate code that you want to be in all of them, right? In all the templates. Then the second type of project Kickstarters are generators. Once you have enough templates, you will see that it's a particularly painful process just to copy a template and try to create a new microservice from it. So the idea is that you want to automate that process too, right? And you want to use tooling that is made for that. In this case, these technologies that I put here, Geoman, Spring Initializer, JHipster, and Atomist, they are usually the ones that I have used to create new microservices from code that is already in a template, right? They just take a bunch of parameters and then they create a new service that is ready to be deployed. They usually take care of all the tasks that I enumerate here, which is renaming projects, add and remove features. In this case, add or remove cross-cutting concerns from your platform. You may not want, let's say, a certain database integration. You just remove it. You want eventing integration, so you add, let's say, a micro library for Kafka or something like that. And then these Kickstarters also take care of, let's say, create the GitHub repository or the Git repository for that new service. They also rename modules. They also replace connection strings. They even run the pipeline. I have worked on that kind of generators. But that's basically the idea behind it. It's like you take the template and you put it on asteroids and you try to make it an automated process. But what are the benefits of doing this? Is basically that is kickstarting new projects. And that means that product development and innovation is cheaper because these generators basically take into account the whole Spring Zero. And Spring Zero in new microservices is like, oh, I need to set up pipelines. I need to set up the repositories. I need to set up the permissions for those repositories. And you can automate all of that with a project generator. You also don't need to guess patterns that are already in the generator. You don't need to guess how to do authentication and authorization in your platform. You don't need to guess how to do tracing, database access, and all that stuff. You remove the guessing from all of that when you create a new service. Even if you have reference architecture, as I put it here, templates should be functional. The point is having those templates is that you will have functional architecture that other projects or other microservices can adopt, and programmers can go and look at the source code and check what these integrations are. And that's where they gain access to reference architecture. And finally, you want to put into these microservices templates and generators. You want to put the best practices that you have for your platform, right? You want to put automated construction like with Gradle or NPM. You want to put all the stuff that you want to save developers from doing all over again. That's basically what are the benefits of the generators. Then another pattern that I have worked in digital platforms is delivery workflow tools. What do I mean by this is, well, if we come back to the monolith era, we had the notion that the continuous delivery pipelines are the one true way to deliver software, right? But then what happens when you have dozens of microservices, right? You may want to say that, okay, I have like also dozens of pipelines, but in reality, you only have like 3 or 4, right? You have, I will say, a correlation between the pipelines, definitions, and the types of microservices that you have. Like in the previous slide, you may have a pipeline for atomic services that will provision also the databases. It will provision the caching infrastructure. It will provision a lot of stuff for you, and that pipeline will only apply to that specific type of services, right? And you may have another pipeline for micro frontends and stuff like that. That's what really happens. And ideally, you will be using one of these tools here, right? to create continuous integration and continuous delivery and continuous release of your microservices. But you also need to enforce platform-wide policies. What do I mean by this? Like, you want all your services to go through code scans, to go through quality assessments and some type of gating to keep your microservices secure, up to date, and also having best practices inserted into those. That's basically what a delivery workflow tool will do for you, but the thing is, it is going to be consolidated, right? So these workflow tools are basically going to be one of the first things that I implement is basically build system integration and tasks. What do I mean by this is basically that you will try to use or reuse across your microservices the same build automation system, right? In this case, if you're using the Java virtual machine, you will use something like Gradle or Maven, and then you will start to see that there are many construction parts that need to be reused across those services, and ideally you want to make them consistent in all your microservices. I will go into why you want to keep them consistent later. That's an important topic on this talk, but basically that's the first type of integration that you want to do. You want to make tasks for deploying artifacts, for publishing configuration, executing additional testing on all your services, database migrations, and other type of stuff, right? Like metrics collection from the build system. That's also a consistent pattern that I have seen when building microservices. And then you will also have a shared pipeline library. In this case, as I was saying, you will have, in reality, instead of having dozens of pipelines, you only have 2 or 3 types. They are duplicated across all your services, right? And a shared pipeline library is basically going to solve that problem. It's going to solve the duplication of having the same construction, deployment, and release logic put into a single or duplicated across all your projects or all the projects that generate a microservice. And you will need to provision many pipelines like that, but with a shared pipeline library, you will save a lot of time doing that. But here's the thing. They allow you code reuse, but they also provide you, like I said before, a paved road approach to deliver your microservices. What do I mean by paved road? That you will know that if a microservice can be delivered with the same pipeline, you will know that you can deploy that microservice up to production, right? And you will have templating for all of that. But it has some catches within it, like you want to have flexibility because not all microservices within your platform may need, let's say, like the same security scans. So if you have different technologies, you may want to have some scanning done with some type of technology, and maybe for front-end it won't be the same tool, right? In this case, you need to add some flexibility in those shared pipeline libraries, and that's like a difficult part of it, but it can be done. Now, as I said, the drawbacks of having these pipelines is that you lost the stability at local level. What do I mean by this? These pipelines are usually run by your CI/CD server. The problem with that is that most CI/CD servers, they do not work with code, right? Like you cannot define, other than Jenkins, I don't know of any other type of CI/CD server that allow you to execute your pipelines using code. They are usually a bunch of YAML definitions, and then those YAML definitions are usually put into a file within your repository, and that's going to be basically the definition of your pipeline. The problem with that is that you cannot test YAML. And by that I mean that the workflow is going to be declared into YAML, but you don't have a way to test that workflow outside of it, right? Or it will be very difficult if you're not using something like Jenkins, in which you can define pipelines as if they were Groovy code. And in this case, another problem with the pipelines is that they are very linear. In the sense that I tend to see as projects grow larger and larger and larger, they are usually take at the beginning, let's say 10 minutes to deploy up to production, but over time they start to go bigger and bigger, and it will take them like 45 minutes to do all of that. So you don't want to also depend on a linear model of a pipeline. There are other paradigms that you can use, like the venting. Like let's say that instead of making your pipeline a single linear model, you could just trigger events that will trigger different construction steps, but they can be parallelized as much as possible, and then can coerce into another event using a different strategy, right? And basically, you don't want to depend too much on your CI/CD server. That's something that I have seen happening a lot. Is like we usually create one pipeline to rule them all, and we try to put as much stuff as we can in that pipeline, and then that makes everything dependent on the CI/CD server. And if your CI/CD server basically goes down or has some downtime, then everything is stopped to halt. That's a huge problem that I have seen many times. And so you want to, even if you have clustering and even if you have other measures to keep your CI/CD server stable, if something happens to it, then it will halt your microservice deployment and releasing. Also, in other projects, I have seen that we try to do that by creating different CI/CD servers for each team or for each microservice, and that also is a problem because then you will have to keep them all up to date. That's delivery drift, but I will talk about that later. So why do I think that pipelines are very bad for the microservice deployment? Is because I think you lose the stability, right? And if you cannot test the code that is going to deploy your services, then I think that's bad, because for me, pipelines and workflows are also software, right? And you should be testing that software because you want to test every software possible, right? And you want to test the integration of that software with the repositories or with the microservices themselves. So you want to create a delivery workflow CLI that will allow basically to take the code of your microservices locally and then try to build and execute the build automation task, and then execute the workflow that happens after that build automation task happens. And you want to keep that approach consistent with all the services types, right? You want to keep that approach consistent with micro frontends, with atomic services and all of that. And you want to be testable locally and detach it from the CI/CD server. That's something that we have built before in the past, and I think it has helped us to get faster feedback regarding that pipelines. Because something that I have seen happen often is that you want to test something in your pipeline. The only way to test it is basically to create a commit with nothing on it. Basically, in Git you can create commits with no contents just to trigger some CI/CD servers. And ideally, you don't want that to happen, because you will have to wait for the pipeline to run until the stage that you're building, right? Or the stage that you want to test, basically. And yeah, those are the benefits that you have, is having testing workflows detached from the CI/CD servers. Application lifecycle is independent of the platform, so that developers can know if something is going to break or work faster. Like, let's say that you want to package your microservice, but you're not sure that it's going to work until you run the whole pipeline. Then with these delivery workflow tools or CLIs, you can test if that is going to happen locally. And then you want to consolidate as much as possible the tooling that you have it in all your platform, because you don't want your developers, one set of microservices using Maven, you don't want another set of microservices using Gradle, you don't want another set of microservices using Node, unless they are front end, right? But you also don't want other front end technologies such as Run or Webpack running in your platform, because then you will have proliferation of tools. That's something that you don't want on your platform, because if you're not mature enough, that this is going to add the burden of maintenance on the platform engineering. And then finally, you're spreading proven workflows of your tools, right? You're with that CLI, with all shared pipeline libraries, you're spreading the knowledge of how to build a microservice within your platform, and you're spreading the knowledge of what are the best practices that you need to follow in order to have a service deployed up to production. Another pattern that I have seen is share build images. As I said, you tend to have a lot of proliferation of tools, right? In some projects, I have seen these drawbacks. I have seen projects where they have a multiple, let's say, very small images with Docker images with a single tool, and then try to execute each stage of the pipeline with that single image. That also adds a lot of overhead to your pipelines. And then what happens if you need to have different versions, right, for your services, because you need to create a special image that will have this different version of Node, because this microservice, this particular microservice does not work without Node. And that's just another problem, which is also called drift, but I will explain that later. The point is that you will have all this tooling spread across different images, and it just adds overhead to the teams that are maintaining these images and are maintaining the tooling for all the teams that are deploying microservices. And that's basically a bad practice. So what I recommend usually is use a single share build image, which will have all of these tools integrated into an Amazon machine image, a Docker image, or Azure Pipeline Agent. Just put them all together. So what happens here is that you will have a single touch point for updates. Whenever you need to update one of these tools, you will have to update it just in one single place, and it will be spread across all the services. And that will give you a faster feedback if some of those services cannot work with that tool, right? If you're using a special version of the JVM to build your microservices or Node.js runtime, whenever you update it, you will see some services breaking, but that's good because you will get the feedback faster that those services are not ready to be deployed into the platform. Then you will have a single agent, which means less overhead for all of that, and you will avoid all the versioning that comes with having a single touch point for updating. One drawback of this, of course, is that the images tend to become very big over time, because as you keep adding characteristics to the platform, you will have more problems. But I think the trade-off here is really good for what you get here with having a single share image. Now, another pattern that I have seen is the use of microlibraries. So what happens here with microlibraries is, like, even in microservices, we tend to go with the share nothing approach, right? Microservices are supposed to do that. Like, it's easier to move code than data. And what you want to have is share nothing between all those services. But I will say that's an approach that is really hard to enforce. The problem with that approach is basically that you will have cross-cutting concerns on your platform. As we broke the monolith into many microservices, you will have logging, tracing, metrics collection, and other type of technologies and cross-cutting concerns being implemented in different ways. I have seen that a lot in microservices projects, because people tend to reinvent the wheel many times. Like, some people will implement logging with one library, metrics collection, they try to create also infrastructure around it. Error reporting and all that stuff, they tend to implement it, but you want to keep them consistent so that you can have the same tooling to be implemented across all your services. But it's also not as small as a function library, right? Like, for example, you don't want to have, let's say, like string manipulation functions into a micro library, right? You want to leave that to those teams. It's not something as small, but you want to enforce it. And as you can see, that's the pattern here. Like, there are things that you want to enforce platform-wide into your digital platform. You want to enforce that into all the microservices that are running there, because it's important for things as reliability and different, how can I say it, and different approaches, right? You want to enforce all of these micro libraries because they will keep developers focused on the business domain of the microservice itself. And yeah, basically those are that's the way that you want to enforce the policies more easily with microlibraries. And you will tackle the drift, because at some point, if you want to update a technology for, let's say, logging and tracing, you can just switch to a new version of the library, and that will be automatically spread across all those services, right? Well, not automatically. Teams to have to take into account that they have to update their versions, but that's another problem that I will explain later. And this is the problem, right? Distributed refactoring. So what happens now that we have all these microservices and then we have new features on the platform or new policies that we want to enforce, right? We have basically this common problem, which is drift. I've been talking about drift in all the previous slides because that's the common thing that happens with all these patterns, right? All these patterns, what they do is alleviate the drift within your services platform. Why? Because this drift happens very often. You will have microservices that are always being worked on because they are very important for the business, and they may not be the most stable services, but they are also doing the innovation within the platform, right? And when you will start kickstarting new services with newer technology, but over time those decisions make that other services, they will be lagging behind, and that's where distributed refactoring comes into play. So what is drift, right? And why it happens is basically because you share code and settings. As I said, you don't want the share nothing approach of microservices because I think it's very hard to implement, and people will start inventing their own solutions for something that is already within the platform. And then you will start to see a lot of settings being duplicated in each service, right? A lot of settings regarding, let's say, authorization and authentication, they will be like, all of them will have to have OAuth settings setting to their setting to each microservice, but they will only change a small value, but they still be there. It's kind of a duplication, right? And then we have different types of drift. Delivery drift happens when your services cannot be delivered with the same pipeline definition over time. What happens when you create a new stage in your library that is going to do security vulnerability scanning? If you just enforce it with a shared library and you're always using the latest version, you will see that most of the microservices will fail to deploy because they will have one vulnerability or another. But then if you're not using the latest pipeline version in every service, then you will have problems because some of them cannot be delivered because the new definition of the pipeline will have a new construction or a new deployment step that isn't enforced when you're trying to deploy, let's say, into Kubernetes or something like that. You won't be able to deploy that service because the pipeline is not up to date, and that's delivery drift. Then we have dependency drift, right? When we started to talk about micro libraries, you will also need to keep those libraries up to date, right? With new bug fixes, with other types of enforcement policies that you need to add. And then if your microservice cannot be deployed because it doesn't have the latest version of the library, or it cannot connect to the, let's say, your authentication server because it switched protocols or something similar, then you need to keep those all up to date. And that's the dependency drift. And then configuration drift also happens because your libraries may have changed the way that you configure that specific micro library, and then you will have, if you just spread it across all your microservices to the latest version, some of them will fail eventually, right? And that's something that happens because of the organic nature of software. But now refactoring within a monolith was easy because you could just go to the source code. It's in a single spot. You could just change, let's say, a tracing or logging statement in every place by just looking at the definition of the class or the function, and then you just update it. But the problem is that refactoring is now a distributed problem, and that's what also causes a lot of drift within the microservices architecture. And to be honest, this has been the vein of every microservice implementation that I have seen, because over time, the drift will start to make platforms crumble. because at some point it adds so much overhead and maintenance. You can see it as a way of technical theft. And we have created strategies to convey that drift and start to allow consolidation of all the technologies that we have. We have created like semantic versioning. We have created other type of meaning in order to convey change, but you should always use latest of the libraries, and if latest is wrong, then you need to keep rolling forward until you fix the stuff. So in this case, this kind of drift makes dozens of disparate pipelines. As I said, you will have pipelines for each type of your services, but if you're not using the latest of the pipeline, you won't be able to deploy that service in particular, right? You will have multiple versions of the same runtime. I have seen that a lot happening in microservice architectures. You will have some services running on Java 8, some services running Java 11, but none of them also can be updated. You will have to have a special tooling for the services that are running on older versions, because it takes some time to update, right? It's developer hours that you need to invest in order to make that to make those services work with the latest and greatest. Again, microlib versions are starting to become incompatible with the previous one. And even if you have semantic versioning, like whenever you introduce a new feature that needs to be enforced, you also need to update all the microservices that are using that library. And that's basically the problem of having a platform with all those services, that they start to drift over time. So again, distributed refactoring is because refactoring became a distributed problem. And we want to keep convergence of that configuration and versions and pipeline delivery. But one thing that I always have said is that the mindset of if it works, don't fix it, that's a problem. Is for me, software that is not being maintained properly is a ticking time bomb, right? You don't want to have services that are using all these versions of the runtime, because it will have security vulnerabilities. At some point, it's going to have problems with long-term support. You won't have support for those runtimes anymore and stuff like that. So it's in your best interest to drive convergence and make everything maintainable and up to date. So there is an interesting concept in biology called ossification, and I have seen people within the microservices community using this term to talk about services that they usually don't keep up to date, right? Whenever ossification comes through, and basically you have a wound, and that wound starts the process of healing. The bone structure around that wound start to make it less and less flexible. And then at some point, if you didn't go through therapy, then you will have a part of your body that won't be able to move as it was before. So that's a similar concept that happens with microservices, because at some point, if you start to have microservices that are too lagging behind in this quadrant, then you will have to create a special infrastructure for those microservices, and you have to maintain it forever, right? And you don't want to do that with software. That's not specific to microservices, but you can see that happening with Rift more often. And then you will have initiatives, right? I worked in some places where they had initiatives to keep those kind of services alive because they were so important to the business, or they couldn't change it without a huge cost. And then they had to have those initiatives to keep them alive and working. But at the same time, they could have saved a lot of developers' hours if they have kept them up to date. So now that we talk about what's the problem with Drift and distributed refactoring, what are the tools that I have used in order to keep Drift at bay? I have used primarily two tools. One of them is Atomist. Atomist has this notion of code that can transform code. And it's basically functions that read the source code of your application, and they do some transformations on them. But the good thing about Atomist is that it can apply those transformations to many repositories at once. So let's say that you want to have a new version of the login library on all your microservices to be updated. you can go specifically to all the Maven or Gradle files and update them with Atomist. But not only that, you could also be, if you broke backwards compatibility and you need to rename some method names, with Atomist you can also do that. You can update both the version and the usages of the function at once with the same code transformation. I'm really a fan of Atomist, but my coworkers, so they are already exhausted with all the times that I have telling them to use Atomist to keep microservices drift at bay. I won't talk that much about that, but the other tool is Snyk. And Snyk is a little bit, I will say, more focused or more specific. Snyk is basically for distributed refactoring of security vulnerabilities. Basically, what Snyk does is that it will go to your repositories, try to check the dependencies, and if they have vulnerabilities, try to keep them up to date. You could do that with Atomist for sure, but Snyk, I think, is really, really good at detecting those kind of problems and then fixes them automatically. As I said, you could do that with Atomist with many programming languages, but Snyk already provides you that out of the box. You can see it as a more specific distributed refactoring tool. Just focus on security. I really like Snyk for that. Well, thank you very much. This was my presentation, and you can find me here. You can find me in social network at Eldermail. I also write a lot about microservices drift and microservices in the context of digital platforms in my blog. You can go there. And I also have a podcast. That podcast is in Spanish because I like to contribute to the Spanish-speaking community of programmers. But yeah, at some point I may like to do something in English too. And finally, I'm writing a book about all of this. It's in this repository on GitHub. It's free right now because legal reasons I cannot get another source of income while being in the States, but that's basically free for now, and later we may have contributions, something like that. And that was it. Thank you very much.